take a look at the first term, displacement. Okay, displacement we are not. Okay, displacement is different from distance. Alright, displacement is different from distance. Displacement is the distance from a specific start point, or in the book we say a fixed point. What do you mean? Okay, I'll use the example that the book says. Okay, let's say this is my start point, or this is my fixed point. Alright, if I travel in this direction, if the distance here is 2 meters, what is my displacement? It's still going to be 2 meters. Alright? But at this moment, if let's say I want to ke belakang pusing, I turn around, I turn back 1 meter. Can you tell me what is the displacement now? 1. Okay? It must be from the fixed point, so now the displacement is only 1. But then, I walk further back, go beyond the start point. Let's say we go beyond, okay, the distance down here is actually, say, 5 meters. Can you tell me, at this particular point now, what is my displacement? 5. But now I want to ask the question, what is the total distance I have traveled so far? There's 2 meters here. There's 2 meters here. Am I right? There's another 5 meters over here. So what is the total distance traveled? 9. So take note, displacement will only tell you the distance away from a fixed point. Alright? In other words, from the very starting point that you got started from. Okay? Any question with displacement first? It can be negative 5, but down here we still take a look at my still 5 meters. But in working, this will be negative 5. In working, but not in drawing. Yes, it means that it goes backwards. Thank you, one thing. Okay? If it's negative 5 meters, it moves backwards. Yes. Okay? Any questions so far? Now, moving on. Velocity. I told you last week, velocity is very similar to speed. Am I right? Yeah, velocity is very similar to speed.
Yes.
But what is the main difference? Direction. Thank you. Alright? This is a scalar. In physics, scalar only tell you the value and the magnitude. Okay? But velocity is a vector. Not only does it have a magnitude, it will also tell you the direction. Take a look at the example again. Okay? Let's say I start from a fixed point. If I talk about the speed, you can talk about speed traveling in this direction. Am I right? You can also talk about the speed traveling in this direction. But when you talk about speed, the thing is, there is no direction involved. So, velocity must come in. And take note, when velocity is positive, there is a higher tendency you are. When velocity is positive, it means that you are moving away. Okay? When the velocity is positive, you are moving away from the fixed point. But when velocity is negative, make a quick deduction. Where do you think you are moving towards? Towards the fixed point, yeah? You are moving towards. And more importantly, velocity is the rate of change of your displacement itself. Okay, it's the rate of change of your displacement itself. Then comes the last one, acceleration. Okay, acceleration is just the rate of change of your velocity in this case. And now I'm going to gather all these three together. Okay, I'm going to put all these three together. Take note, now I'm going to use abbreviation. Displacement, we usually, or rather in all cases, we always denote by S. Okay, we always denote by S. Displacement is in terms of S. Why not D? Because D may be used for distance. We don't want to confuse ourselves. It's used as S. Then, velocity is the use of V. Okay? Because velocity is the rate of change of your displacement. Rate of change of your displacement. Does it sound familiar? Rate of change? Remember when you talk about rate of change, it's with respect to time itself, right? And you want to know what is the change in your displacement, so it's ds dt. ds dt, what does it tell you? You need to differentiate your displacement with respect to time, and you will get your velocity equation. Last but not least, okay, acceleration is denoted by small letter a. Okay, and acceleration will tell you the rate of change of your velocity. Is it getting faster and faster or slower and slower? Okay, in this case, and notice they are all connected. In order for you to find your velocity, you will need to perform your differentiation. Okay, for displacement. Similarly, if you want to find what is your acceleration, you will need to perform your differentiation for velocity to get your acceleration itself. Okay, and you perform a differentiation with respect to time. Okay, differentiate with respect to. Okay, that sort of sums it up. Okay? Question. Now, a few more technical terms. If you remember, what happened when you're at rest? What happened when you're at rest? Not moving, okay, not moving. Another word for not moving? Stationary. Okay, whenever you see all these words, the first thing that comes to your mind, you are not moving. Yes. If you are not moving, you are keeping still. What happened? Is there any speed involved? Okay, so the first thing that must come to your mind when you see these three words, this implies velocity is equal to zero. This is very important. Okay, the use of velocity is equal to zero. Okay, I'm going to tell you all the terms first. Next, initial. I think everyone has seen this word before. Am I right? What does the word initial tell you? Starting, at the very start. Haven't begun yet, right? So at the very start, what do you think is the timing? Zero. Haven't started yet. So when you see this word called initial, you must be able to relate that at the very beginning, t is equal to zero.